Let's look at question 2 for the exam. So in this one, we had 1 mole of A fed to a reactor in which A made P, which could then either make X or Y. So these are all unimolecular reactions. So the fact that A was fed doesn't really tell us anything because this is just a rearranging of molecules. So there's no restriction associated with that. And this just is fixing the size of the system. The container was maintained at 298 Kelvin. Now this is in fact a restriction that we are holding the temperature here. And then it said that the final equilibrium pressure was 3.7 bar. We didn't hold the pressure there, we just allowed it to naturally come to that pressure. Okay? So you were asked to use Gibbs phase rule to explain whether or not this was over or under or properly specified. And so just as a reminder, Gibbs phase rule says that the degrees of freedom is 2 plus the number of components minus the number of phases minus the number of independent reactions minus the number of restrictions. Now, number of components, we started with A and P, X, and Y are made, so we have 4 components. It said in the problem statement that liquid and vapor were present, so therefore the number of phases is 2. The number of reactions shown here is 3. And then the question really becomes on the restrictions. Now, 1 mole of A fed is not a restriction. 298 Kelvin is a restriction. This is a matter of interpretation. Really, this was worded in such a way that it was saying that that was allowed to float and then that was the final pressure that you eventually had. It wasn't actually a true restriction. So I would argue that the number of restrictions in this is 1, in which case the degrees of freedom is 2 plus 4 minus 2 minus 3 minus 1, which is 0. So this is perfectly specified, ready to solve. Now you still have to go out and find the data, find the information in order to do that. If you had interpreted this as restrictions equal to 2, because you were saying that, oh, that was a restriction, okay, I'll argue that it could have been read that way. In that case, you end up with the degrees of freedom is -1. In this case, it's overspecified. Now, overspecified problems can be solved, but you're going to get a wrong answer. It's not going to satisfy all the equations probably, okay, because of measurement error. And so they can be solved, but they can't be well solved. It isn't overspecified. Now, some of you chose to work it, and again, depending on how you wrote your explanation, if you said R equals 0 and you said, I don't want to think about these as being restrictions, I just want to come in and say later that this is what I've already specified, and that's a valid way to approach this. In that case, the degrees of freedom is 1, which means you have one variable to specify, and so we chose to specify the temperature. And so therefore this would be ready to solve a well-specified problem. I think that addresses most of the concerns I had with your work on this question. One person did not know the Gibbs phase rule. A couple of you seem to not remember that it only applied to intensive variables. Okay, thank you very much for your time.